Alright, so maximum value sum by placing three rooks, part 1. So this problem basically states we are given a chessboard and we are asked to place, and it has values in it in each cell. We are asked to place three rooks in three cells such that they are not able to attack each other. A rook can attack each other only when they are in the same row or the same column. Alright. So if they are in the same row or same column, in that case, they can attack each other, and that's not a valid position that I want to keep the rook in. Alright. So, and I want to keep the rook such that I'll use the value, and the sum of those values should be maximum. So in this case, 2, 1, 1 is the maximum I can get. They're in different rows, they're in different columns. So if you look at this example, and by the way, if you look at the constraints, we see that a brute force approach may be possible. And let's take this example. This example, if you look at it, there are three rows. There may be more rows in other examples, right? So in that case, I may not take every value, may not take a value from an entire row. I may skip an entire row because there are multiple rows, right? And same goes for the column as well. Uh, but in this example, there are only three rows. So we have to place three rooks. So we have to use all three rows, right? But if you look at it, in the first row, if I want to choose a value, I can choose only one value, by the way. If I want to choose a value, I will never choose -3. I'll always choose either of the three maximum values that I have in a row. Same goes for this one, 1, -3, 1, or even this one. It doesn't matter because they are all both the same. And for the third row, I can only use these three values. So if we look at it, we are just going to brute force on the maximum three values for each row. We can do it for the column as well, but we are going for this one, we are going to do for rows. By column, I mean I can do the same thing for column. In that case, my solution would be the maximum three values for each column, right? We can do one way or the other. I'm going to use the rows. So for each row, I'll find the maximum three values. In this case, in this example, these three values, and I'm going to do a brute force on this. So by brute force, I mean I choose this value. Now I can't choose 1 or 2. I choose this value. Now I can't choose 1 and 1. I choose this value. Right? That's the brute forcing. And the same goes for the other combinations. And so we have to pre-compute this matrix or whatever we call this. There are few ways to do it. I will be using priority queue since there are only three values. I will be using priority queue to get the three maximum for each row, and I'll store it in a vector, right? I'll store along with its column index, by the way, because at the end, when I'm doing brute force, I'm still going to have to, make sure that the rooks are not in attacking position, right? For that I need both the rows and column. So the rows will be the vector size itself, and inside that I will have, along with the value, the column index as well, so that when I do brute force, I will be able to have access to the indexes so that I can check for the valid position, valid attacking position, right? So let's try to. So for that vector of rows, is going to have two values, one value and the other index. So in that case, I can have a pair of int comma int. One, this will be size row size. This will contain the value and this will contain the index. So let me take the m and n of sizes. Alright, this will be max 3. The row is this, by the way, row size, column size. This is m. I am going to traverse all the rows. For each row I'm going to traverse all the values, but before that, at this point I will define my priority queue. Priority queue. I will have a min heap, min heap because I want the max 3 values. So if you have solved similar problems, then you would already know. But if not, then just let's code and let's see how this works. Priority queue will have this. Um, and finally greater, this will be min heap, and at this point I will traverse the columns, basically the rows I'm traversing at this point. So j is less than n, j plus plus. I will check if the min heap dot size, or before that I'll just add it in the min heap dot push. We'll have the value that is nothing but board of ij, comma, the column index. Alright. So at this point, if the max min heap size is greater than 3, in that case I will pop. Finally, I will, at this point I'll have a priority queue with the 3 max values for this particular row. So I will basically get the values from the priority queue, that is nothing but min heap dot empty max 3 of I dot pushback eq dot pop or top eq dot pop. So this way I will have max 3 populated with the 3 max values for each row along with its column index. I'll do a brute force now. So that is nothing but from this point I will do a brute force as the O of m cube. So I'm brute forcing on the number of rows. That will be O of n cube. Actually, more than O of m cube, around O of m cube. Because for each row I'll have 3 values as well, right? So O of m cube into 3 to the power 3. So, but that is 27 into m cube, which is equivalent to O of m cube. So it's nothing but O of m cube into 27, and that's going from 0 to n. actually m. This is going from j, that is going from I plus 1 to I j less than m j plus plus. Actually, it should go till this point. It should go till this point, and the next one will go for k. I will go from j plus 1 to k less than m k plus plus. At this point, I'll start traversing for each of the values that it has, that is 27 terms of time complexity. So I will check uh, since I am sure that I, j and k will be different at each point. At this point, I will get the values for uh, max 3 of I, max 3 of j, max 3 of k, right? So let me get max 3 of I. That's nothing but a comma b. Yeah, there are two values, right? This is column value, or let me take it like val1 comma column 1. Similarly, this one, similarly this one. So alright, this is good. Let me take this, format this properly. So this is value 2, this is column 2, this is max 3 of j. But at this point I will check if column 1 is equal to column 2, because that can be the case. So I'll do continue. Similarly, this will be column 3 and value, or actually I should have placed this bit here, and the same goes for this point where this will be max 3 of k and this will be value 3, and at this point I'll check if column 1 is equal to column 3 or column 2 is equal to column 3. In that case, please continue. Otherwise, I will have an answer, right? So at this point we need to be careful because if we look at the constraint, it's minus 10 to the power 9. So a sum of 3 cells can go well beyond int min, right? We want the maximum, so we usually initialize with int min, but we are going to initialize it with long this point. This point, so this will be long min. So this will make sure that it covers a scenario where this is the case and it goes well beyond integer minimum. At this point I will check, I will have three values, value 1, value 2, value 3. So answer is equal to max of answer, or uh, long value 1 plus value 2 plus value 3. Alright, let's see if this works. This will be the dominant one, so it will be time complexity wise MQ. Push back. Oh my bad. This should be a vector of pairs. So we have three values for each row, three pairs for each row. Okay. Oh my bad. There is no PQ. Alright, let's see now. This will be a semicolon. It's taking too long. Something might be wrong. By the way, the time complexity for this part is going to be lesser than MQ. That's why I skipped it. But still, let's see the time complexity. We are traversing M, so M of course, and we are having a priority queue where we are pushing at least three values. So uh, and for n rows we are traversing, right? So it's going to be m into n into log of 3, which is essentially going to be O of m into n. So that's the time complexity for this part. I don't know if this is working or not. Let's see. It does, and let's submit it. This is going to give TLE for the second part. Yeah, it works. Thanks, guys.